No, I stole them from here, so he has no room to put his check out.
I think it's pretty obvious. Please, anyone familiar with computers? Anyone beginning with computers? Just so I know how to tailor a presentation.
When we tried any level of like doing your own thing with hardware. Probably. Yeah. Did you like create your own computer yet, or?
Oh, yeah. I'm basically here for the rest.
Oh, okay. How many are just here for the rest right now? Okay. We're going to go through a little bit about the Raspberry Pi at the end. We're not going to go very in-depth with it. But we do have some fantastic resources. We have it here for you to look at. And we can talk to you a little bit about, you know, what we purchased. So, if you don't do that, yeah, you can check these out. Yeah, okay.
I just wanted to welcome you all tonight to our science cafe on how to build a computer. And we have, we're honored to have Caroline Barlow and her husband. Okay, got it, okay. With us tonight. And the library works in conjunction with the Northeastern Maryland Technology Council and the Cecil Business Research Partners to present the Science Cafe program. And just to let you know, probably none of you will come to the one we're having. The next one's in September, but the next one's going to be on livestock. So you all might not be interested in that, but we have a variety of programs out there. So I mean, you know, you're in Cecil County. We do have a lot of, you know, livestock. So and that's what our next one is going to be on livestock. So we introduced Caroline, so she can explain what we're going to do.
So, since this is a science cafe, we did want to try to make it kind of tailored to different levels of experience. We did our best. This is my disclaimer. We are not experts. We're hobbyists. And Steve is actually an electrical engineer, so he does have a background that he's working with. But this is really something that anybody can do. If you have the drive, the curiosity, the patience, and if you're okay with making mistakes. Because this whole thing is a learning process, and a lot of it is going to be driven by you and what you're really looking to get out of any kind of computer that you're creating. So it's all going to be kind of tailored to your individual needs, which means that we can't go over every single individual need presentation. So during the presentation, Steve is going to go over desktop computers. If you're thinking about a laptop, it's actually probably better for you to purchase one free. Bill building your own laptop gets into all kinds of a mess. That you probably, it's cheaper just to buy. However, desktop computer, there are different options that could be more affordable to you, especially if you're going into the higher end stuff and you're doing it yourself. And there's a lot of customization that can happen. So you want to think about doing that on your own. So a lot of the PowerPoint presentation is based on creating your own desktop computer. At the end, I am going to really quickly go through the Raspberry Pi. We have a lot of resources, and the PowerPoint presentation is up here on the desk for anyone who is looking into creating their own desktop computer or starting to do projects with the Raspberry Pi. So any kind of need that you have, we can find you the resources to meet that need. We might not be able to answer every single question, but we're going to do our best. If you're interested in having a PowerPoint presentation and then some other useful links sent to you via email, we have a list in the back. Just make sure you sign it on your way out with the name and email, and we'll make sure that we get that to you. There are a lot of links that he's going to go through at the end that are extremely helpful in the process. So without further ado, this is my husband's teaching. Talk about desktop computers.
Caroline said we tried to write this for a presentation for the novice in mind, or maybe little with knowledge with the computer. So I'm going to kind of go through like a high-level view as to what a computer is, how does it operate, and provide a lot of links and references for those who are interested in building their own machine to be able to search up the parts that they want, be able to determine what they want in the computer, and to be able to implement and build the computer they want. So, like I said, we'll kind of just describe what the computer is at its most fundamental part. We'll take a little bit of a deeper dive into how it's structured and how the general components work. Then we'll help to try to do some guidance as to determine what your needs are, to make sure that the parts are compatible with each other, and provide some references that will enable you to easily select parts for your component, which will be compatible with each other. So you don't have to do too much research trying to figure out if this processor is this, if it's capable of this memory. So there's a couple of references that are helpful in that search for putting your components together. I'm going to discuss a little bit about the assembly of it. I would say roughly 75% of building computers is part selection itself, trying to figure out what you need. The assembly is, at this point in time, relatively easy to snap in components. The connectors are made such that it's very hard to plug in one connector that's meant for a different connector. So the manufacturers try to make things relatively easy to plug in. So we'll provide some references to how to overall build a machine, how we show building the machine itself, and do a couple of things. So we'll provide references to building the machine. And we'll put all the references for installing software once your machine is built. Brief mention as to if you should use Linux or use Windows. So for someone that's never seen a computer before, what is a computer? In its most fundamental basis, it's really just a whole bunch of switches. So millions upon billions now of switches that are within the box. So what it does with the switches is that it's a means of storing information. So there's right now we have transistors, which are a basic device within a computer, and it has an on-off state. So if the switch is off, that's a binary 0. The state is on, it's binary. And most computers, they're grouped up into groups of 8s, which is referred to as a byte. Each part of the byte, each switch is a bit. And by storing memory in this way, you are capable of storing, let's say you have a switch combination that looks like this, as 0s and 1s. You can store this, and this represents the number 83. You look at the ASCII character, this represents a plus sign. If you're typing in a Word document, you push plus somewhere in the computer. That pattern of bits stored in there to how it gets stored as. And it can represent much other information. that we'll have to use for later time. So there's a whole bunch of processing hardware, mainly the CPU, and there's a lot of other company hardware with that, which takes in the user inputs, the mouse, the keyboard, programming instructions, or still a bunch of switches. And all this hardware here is essentially like a bunch more switches configured in such a way that you can do things like shift registers, addition, subtraction. Very fundamental, simple operations thing that enable you to build something like this with a computer with 3 screens and liquid cooling, really fun setup. So play some pretty fun games for my own motivation. Other people do video encoding, some people study cancer research and things like that. I'm using mine for playing some games. So a little bit more of a down low look at what a computer is. And what I have here is a block diagram just to kind of briefly describe how the information goes through a computer and how everything is processed. And what I brought here is a laptop, desktop that I built to try to cross-reference what's going on, which part is which. So in the center of the whole guide, I'll start with the motherboard. Encompassing the majority of the electronics is the motherboard. And I have it shown, it's already inside its case. The motherboard is one big printed circuit board that's here in the back that houses the majority of electronics that is hooked up to the computer. Encompassed with that is the brains of the computer, the CPU, which is actually behind this big honking mess of metal. And CPU has to do so much number crunching and uses a lot of power that produces a lot of heat. So we actually need this big piece of metal for a heat sink to get rid of that heat and pull it away and out of the computer. And we have here the CPU to quickly access memory and do a lot of calculations uses quick acting memory called random access memory, or RAM. So here's an example of what that looks like. This is a DDR3, or what exactly this is. And just to give an example of assembly procedures, say you select your RAM and you select all your parts and you put this all together. A lot of those are the components that are as easy as finding the RAM, finding the slot that it's in, and just snapping it in. Of course, I'm not going to snap it in now. Easier work. Yeah. Good start.
Certifications?
And video card. So goes around the CPU. Video card, here's a pretty basic one that looks like this. And this is essentially a bunch of CPUs all together in one package meant to just make pictures. Running them really fast. And not necessarily needed for most computers, but for someone that's gaming, that has to run a lot of graphics, this is a very useful part. And in theory, it should snap in just like the RAM did. Right now, I'll just put that down. So the RAM is like a short-term memory. There's long-term memory as well, called a hard drive, which I have a mechanical hard drive called, we know it as an HDD, hard disk drive. It connects here. It's not connected to the motherboard, but there's a cabling, SATA cable, that goes. It connects to a SATA port on the motherboard, and then through some other electronics, which aren't really shown here, that information gets conveyed to the CPU, and the CPU can grab information from that hard drive whenever it needs. And within the motherboard, many of them have integrated Ethernet card. So if you want to hook up to internet through a landline, it's already loaded on this card, which is attached here. Audio cards, this one has a 5.1 surround sound. Various motherboards with various different types of sound and different peripherals, so you can go through and search for those. And USB ports, which you hook up most of your keyboard, most of your interface devices through. And there's other types of connections you can do, Bluetooth, FireWire, but the most typical, most common are the USB. So I'll just limit it to that for this discussion. We can discuss more afterward for anyone that's really curious about other types of connections to a motherboard. And the GPU, once it's installed, typically that's directly connected to the monitor, so you can actually see your output. Audio part goes to speakers, obviously. And power supply is shown down here on the bottom, which has typically a bunch of wires that go around and supply power throughout the whole system. So just a quick visual as to what the computer is, a block diagram, and what the components are. So just a little bit more description as to the jobs of each of these components. CPU underneath that fucking massive metal. Its job is to essentially grab the program that you're running, either if you're running a video game or if it's a word processing program. It gets the information that it needs, puts it into RAM, and then looking at the instructions that that program says, it accesses what it needs from hard drive, from what it's getting from the keyboard, and it does whatever it needs to perform the task. Whether that's typing a document, or if that's playing a video game and it shows something exploding. Its job is to take care of water. Anything that involves a lot of mathematical operations. Two of the other major key parts, or one of the major key parts would be the RAM, the hard drive, important but not as much. But when the CPU gets those instructions to run a program, it actually takes, typically it will take the instructions from the hard drive or the solid state drive, copy it over into the RAM, and then use those instructions to run your program. And it does this because RAM is typically faster, but it can't hold as much. So it's a temporary memory which the CPU can quickly get, so playing your games with this program, you're not waiting for something to happen. And then the hard drive is just your general long-term memory. Since the CPU is taking care of many different things, including the RAM, handling the user interface devices, many things, you may need additional help when it comes to drawing a lot of graphics, particularly for people that are playing video games. So that's where the video part comes in to help add additional processing power to help draw the different pictures and everything that the video game is trying to make when you're playing the game. And there's additional audio where some computers will help provide surround sound and different systems that sometimes on the motherboard, sometimes you can buy externally. But a typical desktop computer has those things to display up there. User interfaces, keyboard, mouse, printer, pretty self-explanatory. And the Ethernet card, you need a way to connect to the internet that provides the hardware that will connect either wirelessly or to a LAN. So, at a very high level, that's how the computer works. There's some references later on in this presentation that we can send, which will send you links with a lot more detailed information. We really want to dig into the process of how the CPU works, how all these things work. But one of the objectives I want to do here is to enable someone to have the resources to go out and select the right motherboards and figure out we want the computer to do this, what kind of motherboard, what kind of processor you need. Gives a general idea, give you the resources to find the latest and greatest stuff out there and relatively reliable reviews on that. So it looks like we're going to start with just talking about the motherboard since that encompasses the majority of the parts. So again, this is the circuit that just holds everything. It contains the CPU. So if you have in mind what you want for your CPU, it's great. I typically start with that, so I'll discuss that later. you have the CPU in mind or if you have a motherboard in mind, one thing you just need to make sure of is that the socket type or form CPU can actually fit the board itself. AMD has a company that makes one type of chip, which many types of chips, but has a different form factor that won't fit into the Intel motherboard. So there's various different types of socket types, so that's one thing to consider. And if you don't remember all the different compatibility issues there are, I'm going to show a website that takes care of all that in the future. There's a RAM, which typically now is DDR3 RAM. It's a particular type of RAM that will fit into your given motherboard. If you bought DDR2 RAM and then you have a motherboard for DDR3, it won't fit in there, so make sure about that. And another thing to look at your motherboard is the amount of memory that you support. If you buy 64 gigabytes of RAM, but if your motherboard only can use 32 bits of it, it's supposed to change. So just a key thing to look at when you are selecting a motherboard. Next thing I would say is the expansion slots. So within a motherboard, might be hard to see come up later. But there's an expansion slot here where the video card goes in. There's a couple of smaller expansion slots. This is a PCI 3, these are PCI 1s, and this is a PCI L. But there's different motherboards with different numbers of expansion slots. Typically, the more expansion slots you get, the more it costs. But that enables you to expand upon your computer in the future or add things like a good video card, TV tuner if you want, a good sound card, Ethernet cards. I'm sure there's other additions to computers that I'm not thinking of right now that can be tied into this. So once you have a decision as to all the stuff you want to add into your computer, you just have to make sure that this motherboard is capable of housing all those different components that you have. And right now, typically the PCI Express 1, 2, and 3 are the most common interface connection that's out. And then there's many other peripherals that motherboards can have, which include, but may not be limited to, integrated sound card, video card, USB controller, which should be on pretty much most of them, fan controllers, so that motherboard with a whole bunch of fans to it, and has a bunch of thermistors already located on the board, so if any particular area gets hot, try to pick that fan up a little bit more to keep things cool. And some, but not all, have Ethernet connections. So, and there's some resources later on in here which will help you determine, what extra things you want in your computer, what motherboard to get for that. So probably the most important is the CPU, which looks like the motherboard. I'm going to look at one play. The CPU does all the mathematical operations, so some of the major keys, the things that you need to worry about when getting your CPU, is the operating frequency. So this is usually expressed in gigahertz. Generally, the higher, the faster. Also, the number of cores. So there's many CPUs out there now that quad core, for example, has core frequency within it. So theoretically, if the program is capable of parallelizing or doing things at the same time, you use 4 cores, and you're ready to run 4 times as fast. Doesn't really push 4 times as fast. Makes things run a little bit faster. And that's a key thing to know about. And the socket type, like I said before, the motherboard can really house a particular type of chip, so you just have to make sure that the chip that you select makes with the motherboard that you have. So what I did here for the CPU, I can think of 3 different computer builds that I've seen people do. One's for a high video editing computer, a gaming computer in the high range I put in, and just say a standard computer. So I tried to put in some recommendations as to generally what you should put into a computer if you're going for a video editing computer. So typically for video editing, most of the processing you will be doing is with the CPU, with the RAM. A lot of the mathematical operations that is number crunch. So the typically want to go with the highest end CPU that you can go. If you have your own budget and you want to figure out where to put most of your money, CPU and the FIDO RAM are probably two things that you want to put into your dough in. So just my recommendation is at least a four chip or 8-core, and at least with my research, a lot of people like Intel, in particular, i7s for their hyper, which makes the chip seem like it has double the core structure. And there's a whole topic on that. I'm going to get into with our time here. The middle to high-end gaming computer, CPU is important, but it's not the bottleneck. The graphics cards could be the thing you want to spend your money on there. Something like an i5 processor, even i3 processors are probably good for a high-end gaming computer. So I just wrote down something in the middle end CPU would be a good selection for a good gaming computer if you might have pretty graphics coming out. Computer, of course you go high end, but you're paying more money for performance. Probably one of those. Your standard machine, probably a dual core processor would be fine. Most people that build custom computers are gamers or high-end video. You might be able to find a cheaper. You might be able to build a cheaper computer that's not very powerful. But in my experience, I think you find computers that are not very powerful for about the same price as if you would build yourself. But things change every day. I can go online and find something else that's find a basic computer that would be different. But my general rule is generally want to build a computer if you're trying to customize it or have a pretty powerful machine and save $4,000 or $500 on that. And the general reference, because this is all high level, not a lot of good detail, but throughout this presentation, I'll just show it for the CPUs here, but Tom's Hardware is a good reference for reviews of the latest parts that are out there. And what we do for things like the CPUs, the GPUs, other critical components, they have an updated monthly list that kind of says, here's the latest and greatest at the time. And in the software, you can go on the Tom's Hardware and find all this stuff. But in the presentation, we have particular links to particular sublinks there. But in here, they have a whole list of different processors, and you can scroll down. If you're looking for entry-level gaming, they have their recommendations for things that are $125 or lower, different mid-range, an overall hierarchy chart. And if you're trying to get the best bang for your buck, there's these charts that I typically like. Where if you look at this chart, say for a gaming computer, what this chart has is the iCore 5. And the red represents, looks like playing a game with StarCraft, some benchmark. And then there's a different game, Skyrim, and then a third game they try to Far Cry. The performance of this chip and their setup approached near 100%. I'm not sure what the benchmark is. They have some way of measuring the goodness of the chip. But they approached near 100%, and that chip cost about $200. But then they show if you want to get to 100%, you get this little difference between here and here. You have to pay $600 about for the iCore 7. So that extra $400 is probably not worth it. Tom's Hardware typically has a good resource to try to figure out which parts you should buy and where you should really spend your money. The RAM. Some critical things to know about that is mainly type, make sure it matches up with the motherboard, and the speed. So you see something that says DDR 1600, for example, that means it's DDR3 memory, and it has a speed of 1600 megahertz. And also the kits come in either single, dual, or triple channel kits. But you get a dual channel kit, which is what most motherboards have. Both sticks that have over here are tuned to each other. So these two sticks, really high level, just play well with each other. You can hook them up to a motherboard that has dual channel capacity, which is a lot of today's motherboards. Provides a little bit more performance out of the chips. I'm not sure the reason why. It's a whole study in itself. Just general recommendations for RAM with video editing. High capacity RAM, high speed RAM is probably very important. For your gaming computer, you probably want a lot of capacity, you want a lot of gigabytes, a lot of storage in it. But it doesn't necessarily have to be very fast. There's a reference later on the kind of guide you use to which RAM to pick. The standard, we're making standard web surfing, probably 2 gigabytes of RAM. At least, because that's what Linux needs, so we try to go for it. Video card. So I talked about all this stuff. The CPU has a lot of stuff to do, so if you let the CPU try to draw pictures itself, it will struggle. Can I show this video? Yeah.
There's like a cute video. We did Buster's did an experiment to show the difference between CPU and GPU. And really all it's showing is that the CPU is like very slowly drawing this picture of my face. And then the GPU, all at once, all of the pixels fly out, and it's like, you know, famous piece of work. So it's just showing me that the GPU, if you're going with video gaming, is better, depending on the graphics of the video games.
CPU has like 1 to 8 different cores that are specialized with many things. GPU has thousands or
But it's a fun
millions
video.
of really powerful cores that are just for making pictures. So it's just a fun video if anyone wants to check out. And the just interface type of shit is compatible with motherboard. I'm going to skip all this stuff saying it's compatible with motherboard. And here's another link just to talk about like, the critical specifications on these graphics cards. Not super important. You go to Tom's Hardware, for example. And it gives you pretty much a nice graph saying, here's the best performance, here's the best for your money. It's just shown in this graph here. So for your gaming computer, this is where you want to spend your money on the graphics card. If you have $500-600, I would say go up to there. Get the card you can. If you go over that, you're probably not going to notice the performance difference. These cards can go up to $1,200 plus the themselves. For a video game, for a video editing computer, don't really need a GPU unless you're investing in $1,000 software, which will use it. But in most cases, you buy a graphics card for a video editing computer, it's just not going to use it. And for standard web surfing, just buy a motherboard that has the video capabilities with it. The hard drive. So pretty much a slow hard drive, which is mechanical, holds a lot of memory, but it's relatively slow. And there's the solid state hard drives, which you use instead, which is doesn't hold as much storage, same other programs, but it's very, very fast. So recommendation that I'm usually on is like put included both. I have a hard drive for documents and things that I don't really use very often. And then I use a smaller solid state drive, which has the operating system or Windows on it. So when you boot up your computer, it takes 15 seconds to load all the stuff it needs from the hard drive to the RAM, as opposed to waiting about a minute with the original hard drive. And power supply, typically once you pick all this apart, the major thing is you add up all the wattage of each of the parts, figure out how much total power draw you need, and make sure you get a supply that can handle that power draw. And make sure it has great connections, enough connections to hook up to everything that you need. So that is I'm probably trying to cover an awful lot in a very short amount of time. So what I've linked up here is a video from Newegg. If anyone's going to be building their own computer, we'll probably go there and get everything I just said.
Well, this is a good intro. That is like 2 hours worth of step by step.
So it comes in 3 parts. There's part 1, which kind of describes a little bit better than what I did with how the computer runs, what's in it, and how to kind of pick the parts. Part 2 shows how it's all built, and there's part 2 which talks about building the software. So that's a really good tutorial for newcomers. And the second thing, I always bring this one up, this website called PC Part Picker.
An awesome website.
So I've been talking about make sure this is compatible with this, make sure this is compatible with that, etc., which I can't even keep up with myself. So there's some, I don't know who wrote this, but I appreciate this website. There's this site where you can go in here and choose all the different components you want. So say you did some research and say, like, I want a gaming computer. That's what I'm most familiar with. So then you'll pick a video card. Click here, and what it will do is it will come up with all the video cards that are out on the market. Look at all from Amazon and Newegg, many different vendors. You'll find the one that's the lowest price, apply it out here. Plus all the ratings that that vendor is given for that particular video card, apply that here. Sometimes they have their own benchmarks. So this is the card that I've been looking at that I'm upgrading my computer with. 660. So you just put that. It adds it in there. So I'll just quickly pick the CPU. Let's just say I pick AMD. CPU. So I just pick that CPU. Now if you recall, there's something where I was saying, like, make sure that the AMD CPU fits the motherboard. So if you go choose your motherboard now, what this website will do is we'll find all the motherboards that are possible first, and then throw out all the ones that won't fit, that won't be compatible, and we'll leave you with a list with all the motherboards that have the, looks like this particular chip is the FM2 Plus socket. Remember all the different sockets, and that's great, but I can't. I will usually go to here and make my selections here. So it's a general tool that you can go through, start adding parts, and it will make sure you don't have any incompatibilities. If you choose something that isn't compatible, this will turn up as like this big pink area saying that these parts don't work with each other, and you can go through and make the corrections there.
Strategic warning of exactly what is wrong with it.
And also estimation for the power. You need power for each part, say, spec sheet or each part say, and figure out how much power each thing draws. So this site right here gives you at least the list, which here's all the components that you probably want to do. That you can forward to some forum, and see if other people agree with you or not, or you can just go over and buy them off the bat, like what I know what to do.
Steve,
Yes.
one thing that has not been mentioned yet, the next to one another, are the wiring harnesses standard.
Yeah, well, what you mean between just components?
It goes in, it goes out of cables, gotta go somewhere.
Yeah,
That's what this is all about, is the sockets, yeah.
I think this website will account for that. I need to check.
I didn't see it on the list.
There's a power supply down here. Power supply. So typically, most motherboards are, it's 3 formats. It's ATX, micro ATX, mini ATX. Most power supplies. Pretty sure this has this. Yeah, okay, format. So this is a power supply that's meant to go to the motherboard I selected is the ATX. So that has a standardized set of connections that can go to that particular motherboard. Might have to be a little bit careful because some power supplies have more cables or extra components for the or not. So you may have to actually go to the power supply with its different connections, make sure that kind of both connections going over parts.
What's that, provisions for, adding a second, hard drive?
Yeah,
The cables are there, but do you buy that whole cable in your building?
typically you buy the power supply and it has all the cables that are already coming out for you. Well, there's modular ones where the cables come with it. So you can see a lot of these power supplies you have.
Static cables also.
I'm sorry?
The static cable?
Oh. Sometimes you have to buy that separate, but that usually comes with the motherboards. But I found that sometimes it doesn't, so.
Thing you have for the main power supply for the motherboard is two different ones. For the newer boards, it has a couple of extra ones.
Oh, extra connections?
Yeah,
Yeah, they need more.
Then they say that if you have an older, power supply with a newer board, then you get a conversion that powers both of them then.
Is that a different form factor for it? Is it like
No, it's the same form factor.
same form factor, but?
Yeah, but, when they get the PCI 3,
Yes.
then you have
Then
to
you
have
have
an
an extra-
extra power from the power
Yeah,
supply
like-
going to the motherboard, that point over there.
Yeah. So most of the board, like for this one here, this is an older board, which only needs one of the
Yeah,
power connections, so.
and
Hopefully-
they want you, they want you not to use the old one, because now you have two power wires from your
Yeah.
power supply,
Like this.
and before you only had one, and then you can split it. You have an extra cable for it,
Yeah.
you split that, but all the power has to go to the thin wire from the old one, which is brown.
Okay, so I've had it, the experience that I had when I get a power supply is, you always have it divided up like this,
No, it's in the main.
to the lead ATMs.
Yes. This one over here, and the new one has, I think, three
It has the
inches,
additional
four,
four
three or
pin
something like
next
that.
to it.
For lower voltage,
Yes.
Yeah,
the 2.5 volt.
A lot of times I've seen them where, I think this one actually has it, but it's. This where they actually have. for the
yeah,
old version,
exactly,
you can connect it
exactly
here,
like that, yeah.
and you have that divider.
Yeah,
Um,
but then they get the older ones, they
then
don't
you
have
have
that,
this.
and then you have to plug it into that one.
That's true. I am making the assumption that the power supply company is keeping up with the times.
Yeah,
So
exactly.
typically, when I go search, I have my own preferred vendors. I like Corsair. They seem to put good, they seem to have a product, at least when I've gone searching for it, I've seen good reviews for those supplies. It worked well for me.
Yeah.
But that is a possibility that there might be a supplier that's behind the times that will supply
Yeah.
this, and you need ugly adapters to
Yeah.
try to add in that
Yeah,
additional.
or if you want to, if you want to have to replace a motherboard, then you want to keep your old power supply.
Also,
But most of the time, you want to have more power supply too, if you start adding things.
I think this is 12 volts.
Yeah,
I know there's
12 volts.
adapters that you hook up this, and I think 12 volts comes from here too, but then you get this mess.
Yeah.
So it's,
Would that be listed on the compatibility? You
I'll have to check
select your
that.
power supply, and you've already selected your motherboard.
I'd have to check that, because I think part of that is power supply company times. So, at least in my experience, the couple of times I've built, I've always had something that could be backward compatible. There is a chance that.
But I
there's
think,
supply back
when you buy
Or if you
a,
update something, then you might have an old supply. that you
yeah,
have to
exactly,
convert for.
if you buy a power supply, it has that.
Yeah.
And you can use it for the old and the newer type, right? But if you you use your old power supply for the new power board,
Yeah, then you're,
then you got the throw.
so this is probably good if you're building something from scratch. If you're
Yeah.
building something from old parts, well, I would recommend double checking anyway, after putting it all together.
I
So
wrote
that's-
that particular question down on our email sheet so that we can see if we can address it if you are being emailed.
Yeah.
No, that's actually, that's a really good point though. If you have a good power supply that's sitting around and
Yeah, yeah.
use it, and now it's plugged in,
Yeah, exactly.
so you do messy wires.
But I read in one of these things, from, whatever, when you're changing that stuff to watch out, of course, they say you can use a conversion,
Yeah.
but the wire gets too hot, as to pass too much current. That's all.
Okay, well, we can speak offline.
Yeah.
Yeah, I mean, this website is kind of going on the trust of the vendors, saying that they're selling what they're claiming to sell.
I don't think you can buy any more of the old system.
No, but if you're trying to reconvert, so that's probably a special case that you have to, we're building from scratch, this is probably a pretty good thing. Rehashing, try to be a little bit more cautious and do a little bit more research.
Can you tell me, whether the configuration you have up here will run off the battery, or if it's a wall socket?
That's designed for wall socket. The battery wouldn't have enough power. Actually, well, I'm sorry, energy to actually run it for a long enough time. If you have a big enough battery, yeah, you could run, but then you would have to do some stuff to convert AC to DC, it's a whole, that's a mess.
The word length that you're assuming is 64-bit word?
Word, 64-bit word,
Yes.
should be independent of the structure. We use 64-bit operating system or 32-bit.
I'm just curious, I don't know what the standard word length is, or the standard bit.
What do you mean by word length?
The number of bits that's processed in one block.
No, that's soft, it's independent of, that's, we can talk offline, I'm gonna guess that's either using Windows operating system that's 32-bit based or 64-bit based. I don't think it controls different power or probably some.
I'm just curious to know what the standard word length is for this kind of configuration.
Could be 32 or 64, probably a complicated question. Depending on the operating system, not necessarily these parts that are chosen here. So it's dependent on the software that you put in.
Depends on what you're running on it.
The all hardware is basis of bytes, 8 bits together. And that can be flipped on to 16 bits, and if you flip on another one, 24, then 36. So multiples.
Does the motherboard support all of those?
Probably up to 60. You would have to check with the motherboard. You check at the motherboard, it'll say what operating systems it supports. I would, if there is a limitation for that, I would imagine 64-bit rates that are added to the motherboard.
Is there a video that actually shows you put all the things together without drawing the system, shocking the child?
Yes, yes.
I'm here for my son, he's like, well, he's the ninth grade, he wants to do this,
Okay, yeah, I'll try to speed this along. So there's the first video here that helps you select the parts, and there's that website that's pretty nifty for helping you select parts when you're doing on your own. If you don't trust yourself selecting the parts, there's one website that I know of, Hacks in DC, where if you click this site, this will go to a different site that has 3 different configurations. Yeah, it has bundles. They have their recommendations. It's updated every month. So you kind of go through the parts that are out there right now. For the month of June, they have the recommended budget deals, the recommended gaming deals, the recommended enthusiast build.
Don't you think it is, easier or more secure if you buy a combo or CPU with motherboard?
That's right.
Don't you think that is, easier or less travel, that you buy the combo motherboard and CPU
Together.
together.
Yeah, that's,
Yeah, they come in one package. more or
yeah,
less.
you get it from, like, right here, UA.
Yeah.
Another suggestion where UA is one vendor, but you can click there and they can sell combos where you probably save 10, 20 bucks.
Yeah,
But they hopefully picked the right processor with motherboard, and these guys know what they're doing. That business, they're mixing and matching the wrong stuff, so. They provide a lot of do-it-yourself combos, either motherboard or CPU, or the full machine altogether. Actually, if you click on Maximum PC, you go to the recommendation bills, and then they have a link to Newegg, which has the whole components that's already listed. So you could use that as a baseline, pick that, and then change a couple components within there. So at least these 4 links here seem to be good for this teaching one, how to select parts in general. If you want to go from scratch yourself, this is the reference to help put everything together. And if you want to use someone else's expertise, with Maximum PC, which shows what the expertise you should hook up from the latest and greatest, or Newegg, which is already bundling up a lot of things together. The one caution you have to take is, if you get a Newegg bundle, a lot of times they have a lot of inventory that they're trying to clear out. So you might not be getting a good part within that bundle.
yeah.
One thing to check out for, but at least it's some information that tells you these things will at least play nicely with, not blow up. So, as to your question from before, for building, I put in all these different links. So, it's the first link that I had for the Newegg, how you select parts. Part 2 is the actual construction of building a desktop from scratch. Right, I'll bring out the things, everything from the anti-static bag, the anti-static list, so you don't destroy the parts. What I'm doing now, a lot of people do, but you probably shouldn't, because you probably could have 10,000 notes on it, and you can zap through the parts on this. I've never had that happen, where it's blown up, but in my business, I've heard of a lot of recalls with general electronics, where assemblers weren't very cautious with wearing their wrist straps and grounding themselves. So that might be one thing that's not labeled in there. I'm hoping they put that in there. I think I saw them, but that's one extra recommendation I would say. And here's some other, and there's like other websites as well that is in the video that provides different links in different parts of the stage for you to go build a computer. And you can also just go to Barnes and Noble, which has a lot of PC magazines, which will tell you how to build up a PC from scratch, which are relatively recent. So it's pretty much nearing the end. There's part 3 of that video just talks more about how to install the operating system. Once you have that up and running and tested, and it's working well, pretty much as simple as, for Windows at least, dropping in the CD, putting it in, and turning on the computer, and after a couple of questions, you want to speak English, you're set to go. If you want to save $100 roughly, you go with Linux, but that's, if you're not familiar with it, there's only limited programs you can run. And you may not need some tooling. I'm not very familiar with it myself, so I've done some command lines. For
Like, do it
ease.
yourself.
Yeah. And just general information, so say that you have to build, you already have your components picked out, or you have general questions. Tom's Hardware is my favorite forum to go to, so you can put up your list of parts, have a question, and people will be happy to comment on the build, or give you advice. Sometimes you gotta take it with a grain of salt, but we'll have 10, 20 geeks telling you what to do. And found this other list, which gives like the top 10 list of computer forums, where I think Tom's Hardware is on the top of the list, but there's other forums as well. That's included in there. General information, PC World, PC Magazine, and just the homepage sometimes. And if you're curious, if you have the money and you want to spend it and have someone else build it initially for you, but you want to pick the parts safely. There's these custom builders, which I've never used, so I don't know how good the machines are. But I've heard Falcons get 10 grand, so. But you go there and select the individual parts that you want, and it's set up such that you can. They won't tell you what more you can do. So. That's all I'm doing.
That's okay, that's all right. Okay, so really quickly, I'm just gonna tell you a little bit about the Raspberry Pi. So, we pretty much purchased the Raspberry Pi to mess around with it. And what we did was, we went with the kit. Now, if you're just talking about the Pi itself, without all of the extra components, it runs like $35. But, then, you can't really do anything with it. So, you could piece together the parts for yourself, or you could just purchase the pre-made kit, which is actually pretty cost effective. And now, this is pretty much ready to roll. So, it's got an SD card with a Linux-based operating system already set for you. So when you plug it in and you do the setup, it's like less than 5 minutes to set it up, and there's really basic instructions on how to set it up. Once you get to the point of entry, it looks like a desktop. It looks like a regular computer. So it's really simple. The cool thing about the Raspberry Pi is it's going to give you the capability to do special projects. So if you think about it, everything runs on a small computer. Your cell phone, and your personal, home security system. There are all these different things that are running on little computers, and the Raspberry Pi gives everybody the opportunity to be familiar and to create projects like that. So there's actually, in the kit, there's a breadboard so that you can do more with your Pi. There are a lot of different projects that you can try out. This book we found pretty comprehensively goes through some of the most popular ones. One of my favorites is the MP3 player project, so you can kind of create an entertainment system. Home automation, and then home security controller you can do yourself. And local and remote logic controller. There's some really interesting stuff. Robotic cars. So a lot of different options that you can GPS that you can create on your own with the Raspberry Pi. So the sorts of things that you think about that only engineers in major companies are able to do. Now the everyday person can try it too and can get that hands-on experience. One of my favorite how-to books is Teach Yourself Visually. This is going to walk you through step-by-step with pictures how to set up your Pi and the different things that you can do with it. So with these combined resources, anybody can kind of delve into electronics creation for a really affordable price. The kit itself is about $100, and it includes, the Ethernet connection, power in, power out, everything that you really need is all there. So you can run this like a computer. If you are just interested in having something that you can use to check your email and maybe do some really basic word processing, then the Raspberry Pi will do that for $100, and then you just hook it up to a monitor or a television. But of course, if you're getting into more complicated gaming, more complicated computing, you're going to need a desktop. So it just depends on your particular needs. I would say the Raspberry Pi is, to me, more for the curious person who wants to try something out that you've never been able to do before without these simple electronics. So yeah, it's kind of a fun toy to try out these different projects. And especially for, for teams who are looking to get started in something electrical engineering or something like that, and just give it a try, it's a really great start.
The benefits of your firmware program are interesting. I know what an electrical engineer does. Those little computers that talk to a larger computer like this, they can handle smaller tasks. So where I work, I do stuff where weigh the massive ions, so they control moving ions through means very complex little things that most computer can't control that plus the operating system, but a simple little computer just trying to figure out the forces between molecules. You can program a Raspberry Pi, for example, which has an ARM processor and hook it up to other low-level electronics like FPGAs and stuff, and that gives you the glimpses into what electrical engineer or computer engineer or computer science programs or low-level stuff. It has a programming language called Scratch, which is much easier to use than this introductory point to advanced C# languages that are.
So it'll run like really simplistic coding. So you can learn Python on the Raspberry Pi. It already had Scratch uploaded with all the MIT guys. Scratch is a free website where you can create your own video game. But it's all this like pictorial code. So it's really great for like the youngest beginners in code. They can kind of learn what like the dead language is and do it all visually. And then you can like upload your own images and like create all these games, and it all will run on the Raspberry Pi. They already had a couple of Scratch created games preloaded on there that were really funny and just kind of like fun to do. Something that's really interesting that is a possibility that I mean, we could look into possibly doing even a workshop on is using the Raspberry Pi as a server. So let's say you want to create your own Minecraft server or something like that. You can actually purchase a Raspberry Pi to do that, which is a nice, cheap way to create a server, a single server, to do some video gaming with friends. And that way you don't have to take up your whole desktop computer as a server. You can purchase a Pi and do it that way.
Is there, does the Raspberry Pi run open source version of
I don't know. I mean, it probably would. The only thing that comes to my mind is like something like Google Docs, which would run on Google Docs, which would run on a Raspberry Pi. Google has all of these, like, it's pretty much like Word documents, Excel spreadsheets. It's like the same thing that you would get in Microsoft, but it's like a simpler version. It's not going to have, especially like Excel, is not going to have the capabilities of creating those beautiful charts and graphs that you get out of Microsoft. But if you're looking for a simple word processor to just create a basic document, Google Docs would work, and you can run that on
I've got over 1,000 files in Word, and I need a small machine that I have offline,
Right.
and that'll be those files.
We probably going something like this would be better.
Yeah.
Bet, which is one of the cheaper builds that I've found for $300, which would be able to handle.
I would say
that
if you
Raspberry
wanted,
Pi would probably well more.
if you wanted to save that many documents and you wanted to keep it compatible with Word, then this is not your best bet. But if you're okay with it being all up on the web, then you can use Google Docs. It just depends on what you're trying to do. But something that you want to keep compatible with Word is probably not going to fly on the Raspberry Pi. But you can create a fairly cheap desktop that would do that, but then you're looking at the bulk of the desktop. Whereas the Raspberry Pi is nice little apps. Yeah.
I was this, Raspberry Pi running on batteries?
Run what, I'm sorry?
Is it powered by batteries?
By batteries? No, nope, that
Well,
plug in
You
power.
can power by that.
You could.
it's 12 volt DC. It had, one we got comes with an adapter. I could hook up a 12, you could hook up a series or a 12 volt battery. I don't know how much power draw it has, so I don't know how long it will last. But it is made of an ARM processor, which I think is used in some of the cell phones, so. It's used in a lot of low systems where battery power efficiency is great. But the problem that you have is I don't know if it has the storage space that you're looking for. Remember, which storage for a desktop is relatively cheap. It's 1 terabyte, which is much more than what that is. All those documents we're talking about, it's about $50 as part of this combo. If what you need, you probably need really some of the lower end components.
Where did you get that?
This was the Newegg do-it-yourself kit. So in the presentation that we had, it's this one right here. If you go to Newegg, they have. If you go to Newegg or Tiger Director, all these different companies, they'll have kits that range from $2,000, possibly $3,000 to only $300.
Let's do that. I think that's interesting.
And most of it is online shopping. There are like in-person stores. There's one in Atlanta, right? Okay.
There's USA.
But that's not gonna have
Yeah,
yeah.
Yeah.
That's not gonna have as the options that
That's a
online
budget
shopping is gonna have.
Yeah, I think USA is correct. Now I've gone in there and there's, I mean, you certainly don't have the selection that you would have online, but if you want to look at some stuff, it's actually a good place to walk in and just
Place to get a visual.
give guidance. There's some people there that are pretty knowledgeable. So.
and the prices are the same, right, online.
Are they?
Yep.
Okay.
Oh, they advertise,
Yeah, it would-
Oh, do they?
yeah.
so I never compared it to this stuff. I'm not sure.
We're used to doing online.
In the kit, the adapters, for instance, you say you hook it up to a monitor.
That's not this thing.
I can't do it. So
So
that's
it came with an HDMI.
Okay.
If you're trying to hook it up to not HDMI, you may need an adapter. And I've been online and people are saying crazy things about certain adapters, like that they work sometimes and then sometimes they don't work. And so it's not. This is nice if you've got like a fairly modern television.
Yeah.
You can plug it right in. That's what we did. Just right into our TV. You make an entertainment system. Yeah. Yeah. Streams Netflix or Hulu. Yeah. Absolutely. So that's some of the like practical things that you can do.
Black on
This, yes,
with that kit.
with this kit, with the kit. I'll come to this. And it's got all of these different connectors. So if you're trying to do, if you're trying to do a project that's gonna require the breadboard, it does have everything you need in there. And it's cool, it's got like these LED lights, so you can practice lighting up.
So the general purpose input and output. So if you want to turn stuff on or off, it's capable of doing that. So in college, I basically similar as a machine where I had columns that are upside down, various liquids. And some of that stuff would be controlled by a HC11, much more simplified version of that, which was able to open up the valves and pour the right proportions of different liquids for whatever beverage it is.
One of our friends created an automatic dog treat dispenser, which is something very similar to what we did. So it had like a sensor when the dog wants pets. So yeah, so this is what it looks like without the casing. And it does, this kit sends a case are getting really into 3D printing cases for their Raspberry Pis and doing like fun designs. So yeah, so it's really great for the hobbyists and somebody to give it a go.
We could work on it for hours and hours and hours to save
Yeah.
2 minutes.
Exactly.
It's that obvious so much.
But, you know, for the fun of it.
Yeah.
Does anybody have any questions?
I might stay here a little bit.
I have a-
too, so
I have a
come up and
question.
We can discuss
Before,
personal questions.
what is a road?
What is, I'm sorry?
What is a road?
Oh,
It's a
read only, memory. So it's memory that the CPU uses during boot up. It's not even checking its own hardware at very low level.
Okay.
Stuff, so it could access and read memory, but it doesn't really write into it.
Thanks.
So if anybody wants to like explore, if you want to take a look at the actual components of the computer, you were thinking about checking out some of the materials on the Raspberry Pi, you can come up. And thank you all for coming and.
Is this sign up just for the PowerPoint, or is it also for the links that you have?
It's for the PowerPoint, and then I'm thinking I'm gonna create like a website, like a wiki website that's gonna have all of the links listed. I mean, the links are in the PowerPoint, but it'd be nice to have them on the web as well.
So,
The,
NMTC hosts science cafes through the Elton branch, and in the future will be at the Beller Library in Hartford County. They'll be continuing this in September, and we'll also be continuing in Bel Air into the next year. So, if you're interested, we have a Twitter and a Facebook and a website. You can find us NMTC Connect, and we're also on our website, nmtc.org. Thank you for attending.
Computer vision, electrical engineering, like background.
Sarah.
Information theory, code breaking.
So it's, yeah.
I'm very mathematical.